Hello, this is Mrs. Pullen again for Algebra 2. I'm going to go over some additional problems from the January 2024 Regents. So I'm going to start off with number 20, and these are the mortgage application problems. They tell you Rob is buying a car that costs $22,000 with a down payment of $4,000. He borrows the remainder from the bank. He has a 6-year loan at 6.24% an annual interest rate, and they give you the formula to calculate the monthly loan payment. And they actually want you to find the monthly loan payment. So they want you to find R. And a lot of times people are intimidated because the formula looks complicated, but if you just follow along, you're going to find that these are really straightforward problems. You just have to be careful when you're entering it in the calculator. So we're solving for R in this case. The loan amount, we're not borrowing all $22,000. We're actually borrowing $22,000 minus the $4,000 down payment. So your balance that you're borrowing from the bank is $18,000, or what Rob's borrowing. Now, they want the monthly interest rate, and each problem is different, but in this case, since they gave you an annual amount, you have to convert that annual amount into a decimal and then divide it by 12 because you want to convert it into a monthly interest rate, and that turns out to be 0.0052. And now, what is the length of time that this loan is existing? Well, it's a 6-year loan and it's paid monthly, so that's 12 months. So that means there are 72 payments. So what you're going to do is you're going to substitute those values carefully into your formula, and really carefully. Don't forget that negative sign in the exponent, and that's raised to the negative 72. Now, to save time in this video, I already entered it in. Just a couple of warnings. When you're entering in the numerator, that 18,000, surrounded by parentheses. You don't see the original input, but I had put parentheses around the 18,000 and ending the end parentheses after the 0.0052. I did the same thing in the denominator, and that's how I got it to look like the formula. And when I did that, I ended up with a monthly payment of $300.36, which is choice 2. So just be really careful when entering it in. Make sure the numerator is surrounded by parentheses and the denominator as well. Number 21, they want you to find secant of theta, and they gave you tan of theta is negative 4/3, and they gave you that the angle theta is between pi over 2 and pi. Well, pi is 180, equivalent to 180 degrees, therefore pi over 2 is 90 degrees. So that tells me my angle is in quadrant 2. These are the bow tie problems. So I know I'm in quadrant 2, so I'm going to pretend there's a unit circle, and that's a point on the unit circle, and I'm dropping it a perpendicular line to the x-axis, forming a right angle. From that point to the origin, I make the hypotenuse of the right triangle, and the creases is my reference angle theta. So I write down SOHCAHTOA on my paper, so it's the same trig that you learned back in geometry, and TOA is tan. So if tan of theta is negative 4/3, that's opposite over adjacent. So 4 and 3. So which gets the negative? Well, in quadrant 2, our x values are negative and our y values are positive. Therefore, the negative would be on the 3. To figure out the hypotenuse, you can either use Pythagorean theorem or you can use the 3, 4, 5 triangle. I'm going to use Pythagorean theorem since not everybody knows the 3, 4, 5 triangle. So this becomes 9 plus 16. Remember, when you're squaring a negative, it's positive. That's 25. You take the square root, and c is equal to plus or minus 5. But because you're finding the hypotenuse, it's going to be positive. It has to be, by definition. So we want to find secant of theta. Well, secant's the reciprocal of cosine of theta. So if cosine of theta is adjacent over hypotenuse, then secant of theta is hypotenuse over adjacent. So it's 5 over negative 3, and that's choice 1. Problem number 22. You're solving, they want you to find which is the extraneous root, if there is any. And this is a rational equation. And you cannot just look at the choices. That catches a lot of students because they want to just plug in. But an extraneous root is a potential root. In other words, when you go through the process, you get that answer, but it doesn't work. And so the first thing you want to do is find the LCD, which turns out to be x minus 7 times x plus 7. So for each term, let me do that in red. So for each term, you're going to be multiplying by the LCD. A lot of times students skip this step on the free response, and not only do they make a mistake and get the problem wrong, but they don't get partial credit. You really have to do this step that I'm showing you. I now reduce the common terms, and I'm left with 7 times x minus 7 plus 4x times x plus 7 is equal to parentheses 3x plus 7 times x plus 7. Now I multiply out and I get 7x minus 49, and that's plus 4x squared plus 28x is equal to, and now I'm going to multiply that out, 3x squared plus 7x plus 21x plus 49. I combine like terms on each side, and I get 4x squared, and 28x plus 7x is plus 35x, minus 49, and that's equal to 3x squared. And that's a 7x. I'm sorry, it looks sloppy. So that's 3x squared, 7x and 28x, and 21x is 28x plus 49. I'm now going to subtract 3x squared minus 28x minus 49 from both sides. My internet is being a little wonky right now, so that's why it looks... I'm having trouble writing, is what I'm trying to get at. Okay, so I'm left with x squared plus 7x minus 98 is equal to 0. And when I factor that, I get x plus 14 times x minus 7 is equal to 0. So one potential solution is negative 14, and the other potential solution is 7. However, when I substitute 7 into the equation, it's going to be undefined for that second term and that right-hand side. So therefore, I'm going to reject the 7. That's the extraneous root. And it's extraneous because it was a potential solution that didn't work. -7 is not a potential solution, therefore it is not an extraneous root. So it's only 7 that's extraneous. And that's what I mean, that you can't just like look at the problem and say, oh, -7 and 7, because -7 is not a potential solution. And that catches many a student, but it's not going to catch you because you guys are bright. In any case, I hope you have a nice evening.